continue with the same chapter. So, in the previous classes, we have discussed about what is potential energy, what is electric current, what are the SI units of electric current and potential energy. Now, in this class, we will discuss what is EMF, what is EMF, and what is the difference between EMF and potential energy. So, EMF. EMF is electromotive force. Electromotive force. Electromotive force. So, you know that when we connect a battery to the conductor, then only the production of electricity starts, or then only the electrons will flow through the conductor. When we do not connect the battery, or when we disconnect the battery from the circuit, do we find any electricity? No, we do not find electricity. Why? See, this battery, the battery provides the EMF. So EMF is the reason for the electricity in the conductor. It causes the potential difference, and because of that, the battery causes the potential difference, and because of that, the electrons will flow in the conductor. So what is actually EMF? How do we define EMF? See, when the electrons are flowing in the conductor, when the electrons are flowing in the conductor, at the same time in the battery, there will be chemical force because of the electrolyte in the battery. That electric force, what it will do, it will try to move a unit negative charge. Unit negative charge here is not electrons, here it is negative ion. Negative ion. So, the chemical force will move this unit negative ion from the positive terminal to the negative terminal of the battery. We will discuss in detail about battery in the next class, okay, or in the regular class. Now, the chemical force will move the negative ion from the positive terminal to the negative terminal of the battery. You all know that negative ions will be attracted to the positive terminal. So why? Because unlike charges will attract, like charges will repel. Now, when the negative ion is attracted to the positive terminal, it will try to stay at the positive terminal only. If you want to move, or if you want to remove that negative ion from the positive terminal, you have to put some extra effort. You want to just apply force. Yes or no? See, just take the example of two magnets. There are two strong magnets. One magnet is see, the south of one magnet is facing the north of another magnet. I said that they are very strong magnets. So what will happen? They will attract each other. To pull them away, to move them away, we have to put some extra effort. Here also, we have to put some extra effort, some extra force. That is chemical force. The chemical force, what it will do? It will move the negative ion from the positive terminal towards the negative terminal. Negative, again they will repel. To overcome that repulsion, we have to do some work. We have to apply some force. That force is applied by chemical force, the electrolyte in the battery. So that work done by the chemical force on unit negative ion to move from the positive terminal to the negative terminal is known as EMF. Remember the definition and try to write down in your notes. So by definition. What is EMF? It is the work done, by chemical force. Where is the chemical force? The chemical force is present in the battery. Inside battery, the work done by chemical force inside the battery to move a unit negative charge. Negative charge is here negative ions, positive ions and negative ions. You have idea about positive and negative ions, right? In electrolyte, we will be having these ions. There will be movement of these ions. Okay. Move unit negative ion from positive terminal to the negative terminal. To the negative terminal. So that is EMF. That is EMF. Okay. Now you can just copy it down. Okay. That is again represented with EMF or this small e. What kind of force is applied? Chemical force that we can represent with Fc. Now, how to denote it mathematically? Mathematically, we can denote or we can write it like this. What is it? What is EMF? EMF is equal to work done on unit charge. What kind of charge? Negative charge. So this work is done. See, you all know that work is nothing but force into displacement. Work is equal to force into displacement. Force into displacement. Right? So here also work is equal to force. Which kind of force? Chemical force. Fc into D by Q. Fc D by Q. This is EMF. Okay. Yes. Now we will discuss what are the differences between EMF and potential difference. What are the differences between EMF and potential difference? I will just write it on the board so that you can copy. First, EMF. Potential difference. It is work done by chemical force on a unit negative charge to bring it from positive terminal to negative terminal. Now, potential difference. It is work done by electric field on unit positive charge to bring it from infinity to a point. Okay. Yes. Now the next point here is the EMF of a cell. The EMF of a cell is equal to of a cell is equal to the potential difference between the electrodes of cell when the cell is in open circuit. When the cell is in open circuit, the EMF of a cell is equal to the potential difference between the electrodes when the cell is in open circuit. Okay? Yes? Now what is the other difference of the potential difference? Potential difference is equal to the difference in the potential. Difference in the potential between 2 points. Is equal to difference in the potential between 2 points in the circuit. Between any 2 points in a closed circuit. Yes. Next, again, I will write other two differences between the EMF and potential difference. So, if you want, you can just copy it. I'll wait for 2 minutes. You can just take a screenshot. Okay. Because it will be very tedious and time taking process. EMF is yes. See, in liquid conductor and the battery will be having a electrolyte that we will discuss in the general section or in the next class. I will teach how the battery works in detail. EMF will be there inside the battery also. See that what is EMF? The work done by the chemical force, right? Yes. So that chemical force, where it is coming from? Because of the electrolyte which is present in the battery will be having electrodes. Between the two electrodes will be having electrolyte also. What is electrolyte? Electrolyte is a liquid conductor. Electrolyte is a liquid conductor. Yes. Okay. Now, other two differences between the EMF and the potential difference. See, EMF is independent of the internal resistance of the circuit. It is independent of the internal resistance of the circuit, and it depends upon the nature of the material and the electrolytes. Okay. So EMF is independent of the internal resistance of the circuit. It depends upon nature of the material and electrolyte. Now, what about the potential difference? Potential difference depends upon the resistance between 2 points of the circuit and the current flowing through the circuit. Potential difference depends upon the resistance between. See, I am writing this between in the short form. You don't write like that. Because teacher is writing in the short form, so we will also write like that. Do not follow that. You can write like this when you go to higher classes, not now. Okay. On the resistance between 2 points of the circuit and on the current flowing through the circuit. Next point. EMF refers to the source of EMF. Or electrical generator. Next, here potential difference. Potential difference refers to, or potential difference is a part of the circuit. Is a part of the closed circuit. Now, EMF is the cause and potential difference is the effect. EMF is the cause and potential difference is the effect. It is the cause. Because of this only, there will be a flow of electricity. Now, this is the effect of this cause. Potential difference is the effect. EMF is the cause, potential difference is the effect. Okay, students, you can take the screenshot of whatever I have written on the board. Okay, now we will continue to the next part. Okay, now I have discussed about potential difference. I have discussed about potential difference, electric current, EMF, etc. Right? So, how do we measure practically? How do we measure these physical quantities practically when you will be doing the experiments? When you do the experiments, when you perform the experiments, how do you measure the current and potential difference experimentally? Okay, see, when we come to the current is measured with the instrument that is ammeter. It is measured with an instrument ammeter, and it is denoted with this symbol. The symbol of ammeter is like this. This is the symbol of ammeter. Now, potential difference or voltage. How is potential difference measured? In what it is measured? It is measured with voltmeter. It is measured with voltmeter, and the symbol of voltmeter is this. And the symbol of voltmeter is this. Okay, current is measured using ammeter, and it is the symbol of ammeter. And potential difference is measured using voltmeter, and it is the symbol of potential difference. And remember one thing, ammeter is always connected in series. Is always connected in series with the components of the electric circuit. Once again, I will repeat. Ammeter is always connected in series with the components of the electric circuits. This is very important when you draw the circuit diagram for Ohm's law. At the time of examination point, you may not suddenly remember it, and this is the most important, easiest way to remember it. See, one small logic you have to remember that ammeter is always connected in series with the components of the electric circuit, and voltmeter is always connected in parallel. It is connected in parallel with the components of the electric circuit. Ammeter is connected in series, voltmeter is connected in parallel. Okay. Now, what are the different sources of EMF? We will see what are the different sources of EMF now. We have discussed about EMF, right? We have known what is EMF. What are the differences between EMF and potential difference? Now we will see what are the sources of EMF. Sources of EMF. Cell, battery, electric generator. So these are the sources of EMF. Okay. And we also have solar cells. Solar cells and cells, they all come under same thing, or else you can write solar cells. So these are the sources of EMF. Okay. Now in the next session, we will be discussing some symbols of the components of electric circuit, or we will be discussing about different electrical components. Okay.